All right, so welcome to today's class. We are going to look into the concept of SQL joins. Now, at this point, you must have known that you're no longer at the beginner level of SQL. You are already at the intermediate level of SQL. And after now, we'll be talking about the advanced SQL. And congratulations, you are doing amazingly well. You are doing amazingly well. And today, let's dive into SQL joins. But before we go into that, let's remember the syntax for SQL. First of all, on this workbench, when you come in here, you need to remember how to, first of all, pick the database you are working with. And to know the database you're working with, it needs to be in bold. That's how MySQL Workbench identifies the database you're working with. So if it's not in bold, it will throw an error. It will not even return, it will throw an error. So it's important you understand that anytime you come in here, you double click this so as to select that particular database. And when you expand this, normally it is like this. When you expand this, you get table. When you expand table, you get the columns. That's the way MySQL Workbench is structured. And we explain the concept of SQL, the concept of select statements. And we say the star is the first wildcard you always learn in SQL, and it represents select all the columns. That's what it means. And please take note of this. This wildcard is just the same. It means the same thing in almost all programming languages. It means all. That's what it just means in almost all programming languages. So please take note of that. So select all the columns from this employees table, and where the higher date satisfy this condition. Well, so it's also went as far as explaining some concepts in SQL known as group by, order by, and explain the concept of limits. And limit is found in MySQL. All right, so, and what else did we do? We also did aggregate functions, which is a very important part of every programming, every very important part of a data analyst job. Aggregate function is there, is something you cannot avoid using. It actually gives meaning to what you are doing. So let's move on now to what we are in here, what we're here today, and that is SQL joins. Remember the concept of relational database. When we did the entity relationship diagram. So I'm going to pull out our diagram now so you will see. So we go to database, click on database and reverse engineer. That's the way we get our entity relationship. Okay, so and I want it for only this employees table. Good. So we execute it. So here we go. Finished. Okay, so this is our entity relationship for this employees table. So in the beginning of this internship, you learned how to create ERD diagram for the database you built, and you will attest the fact that it was actually interesting. Now, it is that ERD diagram that will help your tables to communicate between themselves or amongst themselves. And the concept of tables communicating among themselves is what brought about relational databases. So this is this is a database and these are tables. These entities, the relationship they have within themselves, it's what came about the concept of relational databases. So they communicate with themselves to give you a meaningful result based on your based on anything on your query or the business problem you want to solve at every point in time. So let's take, for instance, let's say, for instance, the department employee table has the employee number, department, let me wider, department number, from and to dates, that is, and then it communicates here. So when I hover here, you will notice where they communicate. They communicate on the employee number. So what that means is if I want to get some columns from these two tables, for instance, I want to get the employee number and the employee's birthday. So I want to get the department number, the employee's birthday, first and last name, and the gender. I will communicate the tables. These two tables will communicate on this column called employee integer. The same thing if I hover over this side, department and department employee, you will notice that they communicate on the department number. If I hover here, you will notice that this one also communicate on department number. And this is so easy for you to understand the concept. By the time you hover over the diagram, the relationship, then you'll be able to see how they communicate. Now, sometimes we have that, see what happens here, employees and department table. Can you see the green? Now, what it tells you here is that employees can also talk with the department via the department manager. So the fact that two tables are not adjacent and not linked to each other directly does not mean they cannot communicate. They can pass through a middle table, which we could call a bridging table, to communicate with each other. And this is the concept of the relationship, a relational database management system. And that's what we are going to demonstrate. And that's what SQL Join is all about. That's what SQL Join is going to, help us solve. So the relational schemas will help us to find, the strategy for linking tables. And when you link this table, what happens here is any join you pick will bring out a specified result, a specified query that you want to display. And I think I have said so much, I would like to start demonstrating it. So now, to use a join, you need to use join, you must find, like here, you must find a linking column. So for me to use join for these two tables, I must find a linking column, and this linking column is the employee number. That's the first thing you must understand, that there has to be a way to communicate between the both of them. And that's the employee number. That's the first thing. So then you can get the field, you can then go ahead and pick up the fields, which is the same thing as the columns that you want. And the column must represent the same object. So what does this mean? Let's take, for instance, employee number. When you see, after the employee number, you will see the data type, and it's showing int. Now, if the employee number is objects and in employees table and int in department table, it's not going to work. So let's say here it is just text like varchar, and up here it is int, then they are not going to work. They are not going to communicate. Now, does it mean whenever these tables are the same, what's it called? The same data type, they must always communicate? No, it doesn't mean that. They just need to mean the same thing logically. So the number you see here need to, what the information you have on this table, on this particular column, let me hover here, must match on the same column in the other table. Their name don't necessarily need to be the same, but they need to have the same information in their record for it to work. Does this make sense? Do you have any question on this before we start querying? Any question?
If you don't mind explaining this last one, you said now that it doesn't matter if they have the same, if they don't have the same name.
Yes, so yes, of course. The employees table, I'm using here employees table and department employees table. Now they talk on employees number. Say for instance, the employees table, the column name there is not, maybe fully spelled out as, say for instance, this particular column is spelled out as employee number. Now, at this point, it's no longer the same spelling as this. It's no longer the same name as this. But as long as the data type is the same and the information, like that is the data inside in the rows, the values they contain in that particular column is the same, yes, it's going to work. So the most important thing here is that it needs to be of the same data type and the values will need to be the same for it to work. Those are the two conditions. It doesn't matter the name. The name does not really matter at this point. Well, but why do we mostly have the same name is so that we don't confuse you. So you don't get confused for simplicity. That's why the names are usually recommended to be the same. But are you going to get the same name everywhere? In most companies, you're likely not going to get it that easy. So you will be the one that will need to understand what these things are. And of course, create a metadata that explains each of the table, each of the column, what they do. Does that make sense? Did that answer your question, Francisca?
Yes, it does. Thank you.
You're welcome. Do we have any other question? Ask your question, because we're going into the deeper part of it. Okay. So I take it that we are all doing good. So let's come back here. The first type of join, it's known as inner join. So back in the days, I don't know if any of you, I'm sure every one of you that did mathematics in your secondary school, of course, which I believe you did, must have come across the concept of sets in mathematics. Sets. So I also believe that in that set you would have learned where are my shapes? Shapes. So you would have learned things called intersections. Intersection. Another color. Good. And what's this intersection talking about? So we have this. Everything here belongs to this man. So let's assume this man's name is, okay, so I'll not use man. So this set's name is M. This is N. So everything in this red belongs to M. And everything in blue belongs to N. Sorry, I had to write N in blue, in red, to be blue. But sometimes, somehow, they have something in common. They have something in common. And this place where they have something in common, I color it green. This is the meeting point between them. This is where they agree. You see, outside this space, they don't agree. On the blue side, they don't agree. On the red side, they don't agree. On the green side, this is where they agree. And this is just like the concept of, marriage, where on this side, the woman says no. This side, the man says no. But on this side, there's always something you guys agree on. And that is actually the point that keeps you together. So I hope this concept actually explains what inner join means. So this point where you have something you agree means, let's assume this is a table and this is another table. In inner join, when these two tables meet, what happens is you will be able to query only data that are in both M and N. Again, I'll take it. With inner join, you only get data that are in both sides, that are in both tables. So that's like a common data. If the data is not in N and in M, you won't be able to get it. So at this point, this is what you get. You get only this data, the one inside, with inner join. Okay, so let me use a simple, let me use a little demonstration. Okay, so let's assume I have, this data belongs to N. So N is a table, and this table is, so I would say, I'll call this number. I'll call this sales. So this number 1, 2, 3, 4. I could also call this one another 4, because the sales table can have so many number information there. So I can say 70, 60, 21, and 41. And then we have another table, M. And this M, I will refer it to like the name of the salesperson. So I'll name this, I'll call this name. Then, of course, this is like the sales number. I'll call this the number again. So 1, 2, 3, or the number of the person, 4, 5. And this person is K. I'm using my mouse, sorry about that. The K represents somebody's name. This person's name is G S L C. So in inner join, what really happens here is they are going to be joining on this column, which is number. That's where that is the common denomination between them. And because they are going to join, what we are going to happen, let's say I select this, the employee number, sales, and name. So what we're going to have is number, we're going to have sales, we're going to have name. You know the way we select it in table. So what happens here is, because we are using inner join, it's only the data in both table, the data that is common in both table that it will return. So at this point, it will return 170, and the person is K. It will return, let's say I add another, okay, yeah, let me just leave this one like this. So it will return 2, and the sales is 60, and the person's name is G. To return 3, the sales is 30, and the person's name is S. It will return 4, and the sales is 20, and L. Okay, so it will also return another 1, which is also 4, because we have 2 4s here. It's another kind of sales, and the person's name is L. Now, when you look at this, you notice that this particular information is not returned because it's not in this table. So they don't share this information in common, and that's why it does not return it. So inner join only returns a matching the matching values or matching rows and in all the tables that you pick, or in the 2 tables that you pick. If it's not match, if it does not match, if there is no match, it's not going to return it. Does that make sense? Is this clear?
But
Yeah,
is
it's
this
clear.
supposed to return 4 again? I was thinking it will return only 1 4 because it's just 1 4 in the M table.
All right, so you look at it as a transactional table where you go to shop. Let's say you go to shop in Asda in the morning, and you go to shop in Asda in the afternoon. You will have 2 different records. So let's assume this record is the customer name. You're not going to have 2 records in the customer name, just one. So when you join this, it's going to return 2 transactions for you, and one for the other person, because they only came once. Is it clear, Francisca?
Yes, somehow.
All right, don't worry. Let's move on. You will get this clear. Does any other person have any question? I'm erasing it so we can start writing code now. I just want to, build build a foundation. So that means anything outside this intersection will not be returned. And we will come back to when this other side will matter. Any other question? Okay, so we're good. Please pay attention, everyone. This is not, this is a general class, so it's for everyone. So please ensure that you understand and ask questions where you need to ask questions if you don't understand. It is better to understand it now than want to go and watch video. All right, so let's dive deep. Pick some, let me say department table. Let's pick department table. Select all from department table. So we have all this. This is the department table. Let's select the other one. Which other one? The department employee. Let's select the department employee table. Select all from department employee table. Okay, so how many rows do we have here? It's a long one, 331,000. I think that's a long one. Let's try department manager. I just want to demonstrate things. Okay, this is a fuel table. Yeah, that works for me. All right, so I'm going to run all of them. So the first one is department. This is department manager. So the department, we have department ID, department number, and the department name. Here we have employee number, department number, and from and to dates. So with this, where do you think we can join this table on?
On the department number, I guess.
So department number, let's see, we have department number. So that's correct. Now, notice this. What I'm going to do now, I want to just walk you through the way I will go. So I'm going to select the column name, department number, department name. Then here I will also select the column names. Employee number, department number, from dates to dates. So you see how they are structured now. Now you begin to, the next question you want to ask. First of all, the syntax for inner join is simple. Select column 1 as column name, from, assuming I'm selecting only 2 columns, from table 1 join can be, it is not case sensitive. Table 2, on table 1, dot column name equal to table 2 dot column name. Now, when you look at this, you notice these are the names of the columns. These are the two tables. And this is that column that, that is common between them. With this syntax, it's easy for us to build out a simple inner join. Now, notice that I used the word join. I didn't use inner. That's because I can use inner join, or I can just use join. By default, SQL knows that if you use only the word join, it knows that you are performing inner join. It knows that by default, that's what you perform. And why is it like this? Normally, this is like about the most popular joins you're going to actually do. That you're going to actually perform when you're running in all your codes. So it's important that you take note of that. And whether you say join or inner join, it doesn't really matter. It works. So, and you know how we do it. We just want the shortcuts. We are developers, we are programmers. We don't want anything that will stress you. Perhaps inner join and join will take more, inner join will take more bytes, more space in memory than join, but that's not in practice anyway. I'm just trying to explain to you why it is better to use the short form. Okay, so with this now, I want us to build this thing out. Let us start with the table. So the first table, which table should we use as the first table?
Department.
Okay.
The one that has the employees, the
Anyone can go. It doesn't
departments.
really matter, guys. In inner join, doesn't matter because it's bringing out. It's giving you it's giving you the matching columns, the matching data amongst the both tables. So it doesn't really matter how you structure it. Anyone can come at any time. So the second table is what?
Department manager.
Department manager. Okay. So
But excuse
let's,
me, Kingsley,
yes.
please, I don't quite follow. Where did you get column name, comma column name, and the table?
So
Table
it's
one and
just the
table two.
column name. We have not given it. We are trying to build it out, remember? You know the way you will normally select columns when you're querying your SQL database.
Okay.
So we've not picked any column. We want to build it out.
Like a sketch first.
Yes, that's like a sketch, and that's what we call the syntax. So I wanted to build it out with you. So the departments, we have picked the two tables. Now let us go and pick maybe department name. We want to pick department name. So the first column will say department name. That's department name. Let's go to the next table. I don't want to pick everything. Let's pick maybe department number this time around. Department number. Let's pick another one. Let's just pick from and to date.
But this from and to date are not found in department table. Oh, yeah, they're not found in department table. They are in
Yes.
department
Go ahead.
manager.
Okay. Yes, they are not found in department table. They are only in department manager.
So
That's
why
correct.
are we selecting it from departments?
Oh, but
Yeah,
because
it will not
don't
work.
forget that we are also joining the other table.
Yeah, I know, but I'm thinking we should only select columns that are from a particular table.
So because you want
Yeah.
to join two tables, you are allowed to choose any column from any of the table or all the columns. But that's actually what you want to achieve. If you don't want to get columns from different tables, why do you want to build out why do you want to use join? The concept of join is you join two tables so as to pick the columns you want. Am I confusing you?
No, I think it's
All right. So let us continue. But there's something I'm expecting you guys to say here.
You've not put the employee number now.
Oh, I don't have to put it actually. And again, let us come here. We said they are communicating on the department number, isn't it?
Mm-hmm.
So table 1 is department, and the column name is department number. Table 2 is
So if you're writing the department, sorry, Chrisley, if you're writing the departments,
yeah.
you don't have to write the DEPT, the way you wrote for the department number. If you're writing department, it has to be in full,
I wrote it in
right?
full.
I'm asking, like you can't write it in short form if it's department.
Like maybe the I don't know, like
DEPT,
DE.
the way you're writing the department number.
And so
DEPT, the way you wrote the department number now, you know it's in short form.
yes, so if you want the short form, which we are going to get to in a bit, you will need to also denote it, but let's take it one step at a time. You will see where your question is answered. Just relax. So the second table is, are we good, Lola? Are we good? Is it not Lola? Was it not Lola that asked the question?
Yes, it's IBK. IBK, I'm
Oh,
good.
okay.
Thank you.
Oh, okay. So,
Same.
all right. So now the second table is this. The column name is still the same thing because that's what we are working with. Now we have satisfied this, but I want you to point out where a problem is going to likely, where something that is not up to standard. Yeah, it looks like we're done with our table. Let's run it. Did not run. It's telling us that it doesn't know anything called department number in the field. That it's very ambiguous. Do you know what do you know what the problem could be?
Is it because of the full stop you put after the department?
Yeah, did I put any full stop anywhere? No, it's comma. These are comma. You know the normal way you separate
Not
two
after
comma.
departments, the last line.
The last line.
Department manager, department number.
Yeah, this
No,
semicolon.
not that
That
one.
all these ones.
Yeah.
Oh no. There, I don't think it's not. So it's even telling us that see that the department, it doesn't understand what I meant by department number, like here. It's
Okay.
ambiguous. So it means it cannot relate it to something. Can we think of what could be the problem?
That's because it's not in the
On the table.
what's it called?
Table.
It's there, it's in the two.
Department number. Wow.
May run this other one
Because
again.
So,
It's here now. Department number is here.
it's there. Yeah, it's in the
It's
two.
on the
I
department
think it's
table.
because that's what what's the name now? That's what the pointing, the joining factor. Which English is this spoken? That's what the two of them is using to communicate.
Okay.
you mean
That
the inner
becomes
join?
that's what the two tables are using.
Yes, that's yeah, they are communicating on that. Yeah, that's the communication point, but it's still telling you that it is not, it is ambiguous. So like it cannot really relate it to something. That's like you know, when something is ambiguous, can't really relate it to something specific. So I want
I think
someone to
one of them does not have from date to date. That's why it's hard to connect department number from date to date and the other one.
okay, so it's here. It's on the second table. And we're already saying the second table. Hola? We're already saying we have already joined it on the second table. So you should be able to see it. So, but something is not correct around here. And I want us to think it out.
Oh,
Oh, okay. Oh, the star is not select, or is it?
All right, so for the star, I only use the star when I want to pick
Okay, when
all
there
the
is no
tables.
continuation. Yeah.
No, when I want to pick all the columns, I use star. But when I want to pick specific columns, I just name them. I don't need to use star.
Okay. For department inner join. Or it's because there's no there's no friend, so there cannot be comma.
is it missing a where statement or something?
No, we are not at the where statement, where clause yet.
Select department.
So the place I highlighted, it's actually where the problem is.
From, is it from? Oh, no, it can't be from, sorry.
No, so I've already highlighted, it's around the select. So tell me,
Select,
what do you think could be the problem?
select department
Number from date to date.
from
So
department number. Or is it from department number?
so can you now start
You need to
reasoning like,
remove the department number now.
I don't think
You need
that's the
to
problem. I'm gonna I'm gonna listen to you and remove it. Maybe that will work. Who knows? Oh, that worked.
no. That's if I know what I'm saying.
All right, so let us look at it from this perspective. Now that department number, see all this column you're seeing came from one table, and that's from this table. Oh no, sorry, we have name. Name came from the other table. So now let me explain what was actually missing there. I'll bring back the department number. So what we're going to do is pick this. Where's department number coming from? Let me run this again.
It's coming from the boot.
So this is department. So department name has this. Now I am trying to tell SQL that for you to find department's name, go to department. The same way I will tell it for you to find department number, I want you to use the department. You can see use any of them anyway. I want you to use the department manager. That's the one I want you to use. So what is that What is that telling us? Because there is department number on both tables, SQL query does not know the one to query with, to give you. That's why it says it's ambiguous. But now I'm telling it, give me the one from here, department number. You can still tell it to give you the one from here. And then, of course, this other one from here, it's from this table. Like these other columns are from this table. Now I've been able to tell you where all these columns are coming from. And I should expect it to work well. Now it worked well. Make sense?
Please come again, please.
So what did I do? At this point, department name. Now we're making use of two tables. But we have not told SQL where these columns are coming from. Whether this column is for this or from this other table. Now, without this, the code still runs. The code ran when we remove that. It's the problem.
I think there's an equal sign there. Equal.
Sorry, that's
sign. Okay.
This is the problem. It doesn't. I deleted something there. So now, this column, department name, can only be found in the department table. This column and these two columns can only be found here. That's why this thing went through easily. Are you with me?
Yes.
But we have a situation where let me correct this. Department manager. Correct that. So we have a situation where we have a particular column that belongs to the both tables. I'm running it now. It's employee ID here and employee ID on the other table. ID on this other table. You can see it here. So this employee ID is on both tables. Normally, without this this department ID is on both tables. Without this department ID, SQL will just intelligently understand that these columns belong to this other. It will know the tables they belong to. But it now has a problem because we have a column that is in both tables, and we did not tell it the table it should bring it from. We did not tell the table it should get the department ID from, the department number from. And that's why it's throwing that error. That's why it's throwing the error. That department number field in the field list is ambiguous because it doesn't know where to get it from. But now we said, give each of the column their table name. Give each of the columns their table names so that SQL can easily know where to locate them. And that's why I picked this department, because I know department name came from department, I paste it, dot, and that's how to do it. Table name dot column name. Go to this table and get this column. That's what it means. And we say we want to use for the department number, we want to get from the department manager because it's in both tables, but we want to get only the one from department manager. We'll say go to this table and get us department number. Go to this table again and get us the from table, from date, and go to this table and get us the to dates. And that's the standard way to go about it. Because by the time you have chosen two tables, you want to be able to specify the table each column belongs to. And that's why I put it this way. And that way, it will no longer give us this ambiguous information, ambiguous error. Does that make sense? Is it clear now?
Yes, but excuse me, I have a question.
Yeah,
I
go
thought
ahead.
the goal is to look for values where they have intersection. But how come we're now being careful in
They have
selecting?
intersection.
I mean, how come we're now asking SQL to go to a particular table to sieve out data or values?
But that's what you want to do. The place where the values, the place where that is a match, that's what you're trying to do. But that match, you want to pick up the columns you want.
I
So
don't
the match,
understand what you mean by columns I want.
okay, so you have two tables and you want to pick out table. You want to query the tables. So I want to get employees that are hired between so dates and okay, I want to get departments. I want to get department between so date and so dates. Now, this information belongs to the two different tables. And these two different tables you want to get them from have a particular column they communicate on. And that column is the department number. Because normally what you would do whenever you want to query a table is just the column. That's what you want to query. That's normally what you want to query. But when the table you want to query, when the information you want to get are in two tables, that's where you join the tables. It does not stop the fact that you're still querying. It does not stop the fact that you're still querying, you're still trying to get columns. Because that's what you're trying to do. It's still the columns you're trying to get. But this time around, you're trying to, for using inner join, you're saying go to all of them row by row and see where there are match. If we have an information, so let's say, honestly, I have explained that concept before, and it will take time now to go and start explaining it again. So let's say we have D8, sorry, D15, D0015 in this table, which is the department table. But it's not in this table. It's not in this table. So what happens is when we join them, it's going to return all the columns except D15, D0015, because it's not on this. It's not on both tables. That information is not on both tables. I don't know how to really explain this again because it looks like you're going off the standard explanation. Peculiar?
Yes, please.
Good. Normally, when you want to query tables, you're querying the columns. And each columns, remember, have rows that will follow them. Now, if we are querying this row, if you want to query two tables, you're still querying columns. And these columns will return their corresponding values in them, which are the rows. The inner join, what it aims to achieve is it brings back values that are in both tables, that correspond to both tables. That's what it aims to achieve. Values that correspond to both tables, that's what it aims to achieve, no other thing. Let me try again and explain this.
I understand what it aims to achieve. What I don't follow, where I don't understand is why we'll have to attach the names of the table where we are pulling this information from.
Oh, if you don't attach the names of the table, SQL does not know where to get it from.
Okay.
Don't forget that we have 6 tables here. SQL does not know where to get it from. So it's important to put the name, even though without removing this employee number, SQL intelligently knows that for these table name you have given to me, department name belongs to department, and these other ones belong to department employee table, and it's in department manager table. I intelligently gives it to you, but it's telling you that when you put this, it becomes confused because it doesn't know the table you want it to query it from. And that's why it's important to prefix the table name before the column name. Table name, then dot column name. Table name, dot column name. And then we are good to go. But if you notice, I think it was Abike
But
that
we
told
have
you.
to put,
Yeah, go ahead, ask.
I wanted to ask if you have to put the full name, can we not use alias?
Good. So that's where we are going to. So for us, this is long. This is not standard. Just keep repeating this long name is not standard. So to make it simple, I can say for anywhere you see department, put DP. That's how it is. Anywhere you see department manager, put DM. So now I will go change this department to DP. Change this to DM. Change this to DM. Again, I'll also come here, change this to DP, and change this to DM. See, it looks shorter and simpler.
Just to change one, there's still one you have not changed.
Where? Which one?
The
Oh,
15.
which one?
The 15 department manager. The first
So
one.
that's the name of the table.
And
Okay.
also
And then we list it as DM.
from the department, you didn't claim department.
Yeah, that's the name of the department itself. So
You can't
we are
change the first.
saying instead of department, give us DP. Use DP. Instead of department manager, use DM. That's where we define this alias we're using. That's where we define them, and we started using them on these places. So if you
I thought they
remove,
used to put us on alias.
choose to put, I think we have handled that earlier. You can choose to put us or not to put us, and the standard practice not to put us is okay, especially for this table. So you don't have so many things you have to battle your head around. So this works perfectly well.
Right.
So guys, please take note here because you're asking, why did I not change these departments to DP? this is where you define the what you want to use as department. SQL does not have any, there is no table called DP. There's no table called DM. Can you see here? We don't have any table for like that. That's why when you say from this table department, and then you put this DP here, you're telling it that wherever I am supposed to use department aside here that I defined it, use DP. Wherever I'm supposed to use department manager, use DM aside the place that we defined it. Is this clear?
Yes, that's clear.
Yeah, so it's important we get this right here, because if you don't, it's going to be difficult. And then when we run it, it's going to give us the same results. So this is much more elegant, and this is the industry standard.
But sorry, Kingston.
Yes, please.
Why would anybody want to go through all this stress? Is it to create an extra table from the two tables, or to? I don't understand.
This is a short form.
I mean, this what work situation we will run? Somebody wanted to use this select, join, inner join, and all that.
That is, you mean what's the use case? Why are we even
Yeah.
doing it? Why don't you
What
just use one
scenario?
table at a time?
Yeah.
Okay, so let's look at this. Let's pick up something that makes much more sense now. Find the average salaries of men and women in the company. You know how to find average salary, don't you?
Yes.
Fola needs to respond. You know how to find average salary, don't you, Fola?
Yes.
Now let's find it.
Yes.
Find the average salary of men and women in the company. First, average salary. Select
Right.
average salary, AVG, salary from salaries, isn't it?
Mm-hmm.
That will give us the average salary. That's average salary. Let us again do something. Select everything. Spelling of select. Select all from salaries. That's a long table. Okay, that's a long one, 967,000. Now, this is everything from salary. The question says, find the average salary of men and women in the company. I want you to work with me. Find the average salary of men and women in the company. Paula, can you find the average salary of men and women in the company with this table, this salary table? Can you?
Okay, I think I understand what you're saying now.
No, I want us to just respond. Can you? Let's run it logically so that everybody will understand. You'll be able to find the average salary of men and women in the company with this table alone?
No, there's no gender.
No, I'm asking for Lana. I want us to.
I'll probably need to go to the employee table, find the names and with the gender, then plot out their salaries, then compute the average for each or something like that.
How are
But
we going to do that now?
employees don't have salaries in it.
How are we going to
But
do that?
they have an employee number. There is an employee number that's unique to the employees.
And
Okay.
that's what we used to do the joining of the table, to have a bigger view.
I want to understand, how are we going to do it if we go and find the employee that has gender, the table that has gender? How are we going to do it? To get
We're using the.
I'm not asking you for the query. I'm asking you, how are we going to do it to get the result? I'm not asking you for the query. I'm asking you, what are we supposed to do? The logic. What are we supposed to do to get that result? And average salary of employee, of men and women in the company.
Okay. I probably have to first draw out the male staff.
Okay.
Just like the way we selected the male staff, then you get the average salaries of the male staff. Then you now do a filter to filter out the female staffs.
Well, how am I going to get the average salary of a male? Because there's nothing like gender here on this table.
Yeah, but each of the male staffs have a unique employee number.
Okay, but even if I use that, I won't be able to still know whether the person is male or female using just this table. That's my argument.
We can always get once we get the names, we can always get the employee number from the.
So you want to get employee 100001, then you collect the person's salary. And you go another table and find out if the person is male or female. And then you come back and go to employee 10002 and collect the salary and go back to another table and find out if it's male or female. And then you write, are you going to be able to do that?
Okay, just go ahead.
All right, so now you begin to understand the real situation. Relational database. While it is so convenient to just use one table to run your thing and get results, but in real-time situation, it doesn't work that way. So you're going to have, companies have HR system where they have everything that has to do with the employee in the HR system. Companies have CRM, everything that has to do with the customer sales marketing is there. Companies have project management platform where everything that has to do with the projects they are dealing with, it's there. Now, companies also have transactional database for people who have products, front-facing products, where all the transactions that customers perform, all the daily transaction goes into the database. Now you bring all these things together. You want to make sense out of them. That is your job. It's not an easy job. You will work with so many complex tables. That's why you cannot just work with one table. It has to be with so many tables to make sense out of them. And here is the question. Give us the average salary, and that's the average salary of male and female. So we need to also consider the gender. And gender comes from a table called employee. So let's say we say employee, we represent it as E. Employees or employee. And then we'll join it on the salary, S. So E dot gender, because our gender comes from employee table, E, remember, sorry. Salary comes from salaries table, say S dot S. And then let's name it as average salary, as average salary. Okay, sorry for that break. Average salary. From this table, join it on this table. And of course, you know we're using average, we're using aggregate function. So what does that mean? We need to, well, first of all, let us say we join it on this table on E dot employee number equal to S dot, we have employee number here, employee number. Now, because we're using aggregate function, we need to group by. What are we grouping by? We're grouping by this gender. Still remember your group by. And then when you run this, this is supposed to give you what you're looking for. See? Now that's the average salary. The average salary of male is 63,000 something. So they are somehow close. They are somehow close. So that's it. And that is how you use, that is the true usage of case true scenario where you get to use joins, why you need to join tables. You cannot do without joining tables. All right, I think we have said so many things. And